Hello,
Hello?
my name is Suresh. I'm working
Hi,
as
Suresh. How are you?
the SAP consultant and BW consultant from last 10 years for the one of the reputed institution. I'm here your tutor for the SAP HANA course. Here I will cover entire SAP basics, SAP HANA basics, and in this we have data provisioning, data modeling, reporting, all these things we will cover. And also at the end we will cover the BW and HANA concepts also. Okay. Here
Okay.
today we will start with the introduction of HANA. In this introduction I will go through to what is the HANA, why this HANA is come to this internet world and uh, enterprise world, and what are the futures of the HANA when it compares to the uh, traditional databases and traditional platforms. Okay, let me share my PPT. Okay, this is the introduction of HANA. In this introduction, we will discuss what is the HANA definition, why we, what is the stands for HANA, what is the actual acronym of full form of this HANA, and here we will discuss on the pain points in current situation and how these pain points are uh, resolved through the HANA, that is called reality with HANA, and also we'll discuss on features of HANA. Then we'll go for the question and answer session. Okay. Uh, you may know what is the HANA. You may all know this HANA definition, right?
Yeah.
Uh, yeah. Can you please help me out this definition of HANA?
Sure. Basically, HANA is an in-memory computing engine that leverages cache data to get you the latest information or real-time information at that point after the initial load from whatever data source you guys are looking at.
Yes, yes, exactly correct. That one is correct. In and all, the theme is the HANA is like in-memory database. Here, this HANA is stands for the uh, SAP High Performance Analytical Appliance. Okay, it's not
Oh, it's a
just
very
a
good. Okay. Yeah.
yeah high performance analytical appliance. Here, here we call this as the appliance instead of calling as the hardware, calling as the database, or calling as the software. Here, the appliances means it is like a combination of software and hardware. Okay, let us see. SAP HANA, SAP High Performance Appliance is the data warehouse appliance for processing, as you said, like the for processing high volumes of operational transactional data in real time. HANA uses in-memory analytics, an approach that queries data stored in random access memory instead of hard disk or flash storage. Okay. In traditional databases, what will happen is when we query the data and when we query the database, what is happening? The database reside in the secondary database storage. So that means in the hard disks. To get the answers for our query, what is happening? It will the control goes to the hard disk. There it will fetch the required records and put this information into the RAM. Okay, then only our CPU will read that RAM data and give that results to the front end. Okay, but here when it's come to the HANA, all the data, all the information stored in the in memory. That means RAM instead of the hard disk. So you may imagine like within this, if the all data is there in the RAM, you can imagine like how fast this access of this memory will happen. Okay, there is no input output control kind of barriers now, as this RAM is very near to the CPU directly read the data from the RAM and give the results to the end user. Okay, and in and out, this is the actual definition of HANA, SAP HANA. Okay, let us check now why this HANA is come to this enterprise world. Okay, before HANA is came into this picture, we have a lot of pain points with the current situation of IT world. Okay, here one of the pain point is information explosion. Okay, here if you observe in recent years, lot of devices come into the picture, and we are preparing lot of data, and we are dealing with the lot of data and storing for the lot of data with the personal information also. Okay, so at the time of information explosion, there is no suitable kind of software and hardware available for this deal with this information explosion. Okay, so this amount of data is being created every year. So this data is doubling for each and every year. So to deal with this massive amount of data, we need a certain kind of dedicated software and hardware. Okay, but in current situation, there is no such kind of dealing with this massive amount of data and querying of this massive amount of data. Okay, before this HANA is come into the picture. Okay, this is the one of the pain point.
Okay.
And let me go to the second pain point. The second one is the consumerization. Okay, consumerization of IT. Here, this IT is coming to the consumerization nowadays. So the end users and the people who are using this IT kind of solutions, IT kind of services, they are expecting the uh, information in real time. Okay, okay. Here, if you observe this expectation to make decisions in real time at moment of risk or moment of opportunity. For example, I have a consumerization. I have a what is called service oriented company. Okay, there I need to deal with my decisions based on the data, and the data should be accurate and data should be in time. If the data is not in time, what will happen? I can lose my opportunities. So nowadays the people are expecting instant answers. Okay, that answer should be correct answer. Okay, they want them to write, they want them to anywhere and anytime. Okay, so the consumerization of IT come into this kind of situation. The all the information, the all the right informations they want in any time and anywhere. So in past situations with the traditional data, there is no such kind of situation. There is no real-time querying of this data. Okay, what will happen? What was happening is like they have batch processings. The batch processings will run in over the night. Then only we will get the data. Whether the data is correct or not, we don't know. Why? Because that is the near real time. Okay, during that processing of data, there may be some transactions happened again. Okay, so that kind of gap is there with the traditional databases. Okay, this is the second kind of pain point with the consumerization of IT. When it's come to
Okay.
the third pain point is like IT cannot deliver. Okay, IT cannot deliver what business need. Okay, uh, here in traditional databases, IT always not deliver what actual business needs. Why? Because here we have uh, actually this puts in a tough situation in traditional databases kind of situation. Okay, IT cannot deliver what business really need. Why? Because of the cost of managing that information exposure too high. Okay, because the cost of managing this information exposure, that means the cost of storing all this kind of data into the devices and handling those devices is very costly. Okay, because there is no practical way to instantly analyze everything that is going on relative to the business. Okay, uh, At that time, there is no kind of practical kind of situation there to analyze entire data. Why? Because there is no situation to handle the massive amounts of data, so they cannot analyze all the data at a time. Okay. As of now, IT can deliver only some of the required information. So what they have done is like they get the only golden amounts of data. That means only the really required data. So they can analyze that data only. Okay, instead of analyzing entire the data. The most critical slice of information can be delivered in near real time only. Okay, not in real time, but is not enough because data is growing and demanding is increasing. Okay, so the analyzing of this slice of information and from entire the business is not enough to show the actual dashboard of the business. So they have to deal with massive amounts of data. Okay, and they have to deal with the data growing and demanding is increasing. Okay, so to face the challenges above, we should align. Okay, the face challenges this cost effective of the managing of large data volumes and the immediate answers in any queries. Okay, and current corporate and current and complete information. All these are the pain points with the traditional database. To deal with this one, we need to dedicated software and hardware to deal with this cost effective large amount of data, immediate answers, and current and complete information. Okay, so these are all the actual pain points when it compares to the traditional databases. Okay, so in reality, HANA come up with a solution for all these pain points. Okay, in reality, the role of HANA is like using groundbreaking in-memory innovation and in-memory and software. It using the in-memory software and hardware. So it handles a massive scale of data with amazing speed and flexibility to the dealing with this data. So HANA will deal with the massive scale of data. So it can deal with any kind of information explosion. Okay, and also with the massive amount of speed. Okay, amazing speed, like it can deal with entire data with very high speed and also flexibility. So there is a flexibility with HANA. We can create our own kind of data bases. We can create own kind of data marts. Uh, so there is no aggregation for each and every level. Okay, there is no need to aggregation for each and level with this within this data. Why? Because in traditional database, what is happening like we have to put the certain related data into the one place and will aggregate the entire data to get that data is the to make that data is the smaller one. Okay, so as this HANA has the massive scale dealing capabilities of massive scale of data with amazing speed, there is no need for the aggregations. On the fly, it can aggregate the data and give us the actual answers. Okay. Any queries up to now?
Sorry, no, I'm good. Go ahead.
Yeah. All these are the theory only. I am giving this kind of theoretical information. Okay. As of now. Okay. Now let us see. Here we have SAP HANA in-memory appliance. Okay. That means this is the architecture explains the main components and capabilities. Okay. Here, HANA is a platform. It's offered as an appliance. Instead of software and hardware, we are calling this as the appliance. Inside the platform is our ability to use both SAP HANA as database or application platform. Okay. Here we have this HANA as the appliance. We can use this HANA appliance as the hardware or database or kind of platform. So at its core, HANA is there First of all, it's a database just like any other databases with the capabilities of other databases does not have. Okay, this is an SAP HANA is also database, but it has the additional features that the traditional databases does not have. Okay, so HANA is the appliance is combination of in-memory uh, software and hardware. Here, the in-memory software is designed by SAP vendor, and the hardware, what is the suitable hardware, designed by the different kinds of vendors like HP, IBM, Fujitsu. We have a number of vendors. They provide the hardware kind of uh, uh, details to the SAP. So these hardwares are designed with respect to the SAP HANA software, in-memory software. Okay, and also we have data modeling and data management. Okay, here when we see this diagram, this is the very simple architecture. Here we can see the SAP HANA applications. Non-SAP HANA applications are the databases, the external things. Okay, here from these applications we can replicate the data. Okay, we can replicate the data into the HANA database. Okay, there are a number of replication techniques. Here in this diagram we can see the real-time data replication and data services. Okay, once we replicate the data, we can do the data modeling and data management. Okay, and here we can see real-time data replication. We can do the real-time data replication whenever the posting is happen at the SAP system, the transactional system. Immediately that posting will be posted into the SAP HANA database. Okay, that is called the real-time replication. And also we have data services, the BODS. Okay, with this BODS capabilities, it has the ETL capabilities. With this also we can replicate the data from the SAP and non-SAP systems. Okay, but it is not a real-time replication, but it is a near real-time replication. Okay, here with this replication technologies, we can replicate the data and we can model the data. Okay, these models are run on this calculation engines, and also we can store the data here, the data management. If you see this data management, here we can maintain the data management within the row level or column level storages. We have kinds of tables like row tables and column tables. With these tables we can maintain this data. Okay, along with this we have capabilities enabled with this SAP HANA, like analyze information in real time at unprecedented speeds on large volumes of non-aggregated data. Okay, as we discussed earlier, this matches with the real-time replication and unprecedented speeds on large volumes of data without aggregated. If the data should not be aggregated. Okay, it can handle the non-aggregated data on the fly. It can aggregate the data. Okay, we can also create the flexible analytical models based on real-time and historical databases. For example, from here we have the real-time data. From here we have the historical data. On combination of real-time and historical data, we can create our own flexible analytical models to see the actual answers. Okay, and also we have foundation of new categories of application, like we can deal with the planning applications and the simulation applications. Okay, and also we can have the minimum data duplication. Okay, why? Because there is no aggregation, there is no need to create the aggregations, so no need to put the chunks of data into the different places. Why? Because on the fly all aggregations happen within the HANA, so we no need to go for the aggregated data placed in the different places, same data placed in the different places. Okay, these are all the actual simple diagram of HANA and its capabilities. Okay, any queries here?
No, go ahead.
Yeah, Here we are talking about this HANA is super, HANA is that much, HANA is this much. Okay. Here we boosted this HANA. Okay, as of now. Okay. But where is this actual proof points? Here we are talking about the amazing speed. We are talking about this very high performance and very this means amazing speed, like it can deal with the large amounts of data. But where is this proofs? Okay, here we have this HANA introduction of HANA. At the time of introduction of HANA, SAP has come up with these proof points when it compares to the traditional database and traditional kind of softwares. HANA is the 3600 times faster reporting speed. Okay, and also it can deal with the 460 billions of records less than a second, and also it has the average increase in memory. Okay, here how these pain points come into this picture, how we can define the 3600 of 3600 times the HANA is dealing with this fast reporting speed. Let us take this one, like this 3600 times will come like this. Okay, at the time of when it comes to this amazing speed proof point. Okay, SAP HANA tested the scenario for one of the pilot customers. Okay, one of the pilot customers at that time, and took the report for here one of the report. They took report from the pilot customer. Okay, that report actually runs on the traditional database. Okay, traditional database. Okay, here we have HANA. Okay, actually this report runs in traditional database. This is the report of the one of the large customer. Okay, at the time of pilot projecting, they can observe the same report took 1 hour to get the actual answers. Okay, HANA has replicated same data into the HANA database, and they run the same report, the same query. What this report is having, the same query HANA has run. They have get this answer within the second. That means you can mathematically we can imagine 1 hour means 3600 seconds. Okay, like this, they have come up with this 3600 times of speed when it compared to the traditional database. Okay, here this is the one of the pilot project they have done. In traditional database, we have a query that took 1 hour of time to get the answers. The same query took 1 second with the HANA. Okay, like this 3600 times faster reporting as defined. Okay. Next, we have 460 billions of data. That data HANA can handle with the analyze this 4,460 billions of data within the second. Okay, here we can see the another frame points,
Quick question.
the proof points.
So
Yeah,
460
please.
billion, is it a row or what exactly is that?
Pardon. Uh, four,
The
460 billion
460
records. Yes,
records, okay, that makes sense. Okay.
yes. These are the records. Data records analyzed in less than a second. Okay. Here we have very large SAP also what is piloting on the very large bank sector kind of organization. Okay, they have observed like they took the queries from the bank, and they actually they're running their bank operations on the traditional database. Okay, here if you compare this data compression with the HANA, when they get this traditional database, okay, the actual data volume, okay, the actual data volume that took the same data is the 41.9 gigabytes, okay, the same data, okay. When we replicate the same data into the SAP HANA, okay, it's moved into the 6.6 gigabytes without losing the actual content of this data. Okay, so here we can see the with the HANA we can go for the data compression also. Okay, the traditional database will take the very large amount of database to keep this to store the same kind of table, but HANA took the very less amount of memory utilization. Okay, this is the one kind of proof points with respect to the data compression with the SAP HANA. Okay, here also query runtimes we can compare. They have took 3 queries from this banking sector customer, and they run this 3 queries at a time. Okay, if you observe like here, the first query took 2660 seconds. The same query in the HANA took 5.1 seconds. Okay, like this. There are differences, very huge differences with respect to the traditional database when it comes to the SAP HANA. These queries are took by the SAP without changing the schema changes, no data changes, and same SQL they have run, and they get the immediate benefits. Okay, these are all the proof points from SAP when it HANA is introduced at that time. Okay, now we'll discuss on the futures. Here we have given the proof points of HANA. Now we'll discuss on the futures of HANA. Actually, the HANA database and HANA appliance having these 3 futures. Okay, one is the in-memory database, and parallel processing, and column-based storage. Okay, first of all, SAP HANA is in-memory database. Okay, that means all the data and all operations happen in the in-memory only. Okay, instead of hardware hard disk, we are dealing with all the data within the in-memory only. Okay, it's not like a catching the some information in the main memory and perform some operations in the cache. It's not like that. All operations happen in the in memory only. Okay, because we know all operations are performed in memory, we can really optimize the software of the database engine, knowing that we are always going to have fast memory access. Okay, that is the known thing. Okay, computer architecture has changed in recent years. Okay, when it introduction of the HANA, due to this HANA, the computer architectures are changed in recent years. Now, multi-core CPUs are standard with the fast communication between processors here, like this. Okay, here now within this hardware we have very huge amount of evolutions are there. Now, multi-core hardwares are available now to communicate with the fast communications. Okay, there are processor capable parallel processing. Okay, main memory is a no longer limited resource now. Okay, we can the companies and the main memory cost is reduced very low, so we can go ahead with this any kind of extension to the main memory without affecting the cost of the organization. Okay, modern servers can have 2 terabytes of system memory, and this allows complete data to be held within the SAP HANA. Okay, the complete database of organization can held within the RAM. Okay, nowadays we have 2 terabytes of system memory, and we can extend, we can scale up all this system memory based on the organization. Okay, based on our organization requirement. Okay, so overall, this HANA is having the in-memory database. Okay, so with the increasing of number of cores, Okay, CPUs are capable of processing increased per time intervals. Okay, here uh, we dealing all data within the in memory with this combination of evaluated hardwares. Okay, here the same memory read from the different cores. Why? Because within this hardware we have a number of cores, and within the core we have 8 CPUs. Okay, when we query the particular table, what will happen? The all CPUs, what are the available CPUs? For example, I have 8 CPUs within the core. All CPUs will work on that particular single table. Okay, so in this case, there is no anyway there is no kind of IO operations within the in memory. So all CPUs directly work on this table. So in parallelly it get to all information. Okay, and club this information and give it to the end user. Okay, this is the in memory capabilities from the SAP HANA. And also we can see here this is the traditional approach and future approach with the SAP HANA. In traditional approach, all data is placed in the database. Okay, what are the operations we are going to perform? What we have done is like we'll fetch the data from the database and keep this data into the application layer. Why? Because at application layer only we can do the calculations. Okay, once the we done with the calculations at the application layer, again we push the data into the database. Okay, so this kind of five operations are there at the time of classical approach. The calculations happen in the application layer only. But with the SAP HANA, all calculations happen in the database layer. Okay, so no need to uh, go to the application layer, come catch the information and push back this data into the database layer. All operations happen in the all calculations happen in the database layer only. Only thing we can just query the database and get the actual result. Okay. Any queries in this in memory concept and future approaches?
Yeah, I did want to add something like so. With respect to the given architecture with HANA, how would you compare HANA and Hadoop at this point? Because both of them are dealing with big data at that point, aren't they?
Yes, this Hadoop is big data. Okay, here HANA is the dealing with the big data. Okay, there is a difference. In Hadoop also we have massive amounts of data. To deal with this massive amount of data, we need to special kind of algorithms and special kind of software and hardwares. Okay, here the HANA is dealing with this kind of data also. Okay, the massive amounts of data HANA can handle with amazing speed. When it's go to the Hadoop or there, the different kinds of traditional databases also there. They get the data, huge amount of data within their time limit only. Okay, but it compares to the SAP HANA, it deal with this big data and get the data in amazing speed in real time also.
Okay.
Okay. Okay, now we'll see the another feature like parallel processing. For example, we talk like we have cores and within the cores we have a number of CPUs, right? For example, if I have two cores, okay, here and we have or and I have four cores within my database. Okay, here I'm dealing with only one single table. Okay, here with this parallel processing, what will happen is like each core working on the single column. Okay, here core 1 working with the column A, core 2 working with the column B, and core 3 working with column C, and core 4 with within this column C we have some segregation again. Okay, with this segregation core 4 working. Okay, so if you this parallel processing happening within the single table, you may imagine like how much speed the data will get from the database. Okay, so this is the combination of hardware and software capabilities. So with this hardware capabilities, we can do the parallel processing on the tables, or on the databases. So without without providing the idle time to the CPUs utilized with the different to parallel processing operations. Okay. The third feature, like a column-based storage. Okay. Here in traditional databases, we have the storage like uh, row storage. Okay. When it comes to the HANA database, all the data stored in the column based. All the data by default stored in the column database. We may store the data in row based also based on our requirement. Okay. But the column based storage data, column based storage kind of tables are suitable to do the analytical applications. Okay. Here, let us take the example like we have one table: customer, country, product, and amount. Okay. In row based storage, all the tables data stored in the row level only. Okay, like this. In the tuples, tuple 1 we have 001, like this. Okay. Here you can see this, the same table I have. Here the graphical representation for the storage. We have tuples of storage, but in column storage we have all columns, the related columns stored in the one place. When it comes to the country related information stored in the one place without duplicates. Okay. Product information stored in the one place. Okay. All the column related information stored in the one single place only. Okay. So with this, if you store this same information stored in the same place, you can optimize the current hardware. Okay. With this, for example, I have customer. This customer having the 100, 200, 300. This data type is like integer. We can imagine like this is the integer. Okay. Let us assume it took 4 bytes. What will happen as this same data type of data placed in the same place within the database? So the memory addresses are placed in the same place. So when the same memory addresses placed in the same place without splitting into the different places, there is no need to go to the different places to get the same kind of data. Okay. So here we have the optimization of the hardware, and because of the same data type placed in the same place, there is no wastage of the memory places, the memory address places. Okay. So with this we can compress the data. Here let us see this table here: country, product, and sale. Store the in row 1 we have US, alpha, and 3000. When it compares to the column storage, what is happening? The country stored in the single column. The country column stored in the one place, and product column stored in the another place, and sales column stored in the one place. Okay. It's stored in the conjugative memory locations. Okay. It's stored in the conjugative memory locations. For example, let us take this memory location is 1001, and this memory location 1002, 1003, like this. Okay. For example, if my table is stored in the row based storage, when I want to get one single row from the database, okay, I want to get to this first row, US, alpha, and 3000. Okay. When I want to get this database record from the database, if I query this database, what will happen? First, to get this one, if my data is stored in the row storage level, first the control goes to the 1001 column, 1001 memory address, and it will pick that 1001. Okay. Next, it moves to the 1002. Okay, here, but we don't have any kind of consecutive memory locations. Why? Because this US is the one kind of data type, and it has the one kind of memory allocation space. So it may have the 1001. The next record will place in the 2001. So to get the same record, it has to traversing within the with the different kinds of memory locations. Okay, within the hardware. But it comes to the column storage, all the information, all the related information placed in the same location. Okay. So to get this one, I just go to the one memory location. Okay. And immediately I have second kind of memory location. Then I get this record and third level memory location. Okay. This is the hardware kind of explanation. Let me show one more diagram. You can clearly understand that one. Here we have conceptual view on the column data storage. Okay. Here we have columns like A, B, C, D. The blue line is the one column, the green line is the one column, and red line is one column. Okay. When it goes to this one, when it compares to the memory mapping of these columns, the blue lines, all the blue lines scattered into the different memory locations. Why? Because this data stored in the row-based storage. Okay. When it compares this same information in the column-based storage, it organized by the column-based. So all the blue related information placed in the consecutive memory locations. Okay, and all green information placed in the one place. All red information placed in the one place. So accessing of this memory addresses are easier when it compares to the row-based storage. Okay, so that's the reason why the analytical applications always go to the column-based storage kind of approach. Okay, so with this column-based data storage, we can get the benefits like optimized load of data to CPU. Okay, loading of data to CPU is optimized. High data compression. Okay, so there is no scope to wastage of the memory location addresses. Why? Because we can store the all the data in consecutive memory locations. There is no wastage of the storage, so we can optimize the data storage with the HANA database. Very fast data aggregation and makes use of real life full data tables. Okay, these are all the common features of the column data storage capabilities within the HANA. Okay. Here we can see HANA database. Why this performance reasons for this HANA database? As we discussed earlier, this is the combination of hardware and software. When it compares to the hardware capabilities of HANA is like it has the multi-core architecture, 8 CPUs for each core. For example, if you take one blade, within this blade we have 10 cores, and each core will have the 8 CPUs. Okay, so with this memory hardware capabilities, we can do the parallel processing, and also we can have the different 40-bit address space. Okay, so we have advantages with the hardware capabilities, and also we have advantages of the software capabilities. Here we have software capabilities like row and column storage, compression, partitioning, and no aggregated tables, and insert only on the delta. Okay. With this combination of software and hardware capabilities, we can get this amazing speed on the massive amounts of data within the HANA in real time. Okay. This is the introduction. Actually, with this HANA, we have data provisioning, data modeling, reporting, and security kind of concepts. These are the basic concepts actually. Once these concepts are covered, we have advanced kind of HANA concepts also. Those things we can cover in our entire course. Okay. Any queries? for understanding point
Yeah,
of
sure.
view?
So like I've worked with HANA before a little bit. Uh, I was wondering what kind of advanced reporting that you mentioned that you'll be going into.
Yes, yes, yes. In advanced concepts, when it's when it comes to the data provisioning, we have data provisioning concepts like SLT, BODS, and a normal kind of flat file extraction kind of things. In advanced thing, we have the SDA and SDQ also. Okay. Uh, Through data with this SDA and SDQ, we can see the advanced kind of data provisioning capabilities of the SAP HANA. Okay. And also coming to the data modeling, we have the data modeling like simple kind of SAP HANA kind of artifacts like analytical views, calculation views. But in advanced kind of modeling, we can deal with the calculation use with the advanced kind of features. Plus, we can deal with the mixed kind of modelings. Okay, we can get the data from the BW, and we can get the data from the native HANA, and combine the different kinds of models within the mixed kind of modeling. Okay, and also reporting, we have different kinds of BO kind of tools to access this and SAP HANA data views directly. So we can deal with this SAP sortable reporting tools within this reporting. And also security. Here in security, we can deal with this user management, how the roles are provided to the users, and also how we can restrict the particular user to see the row level securities. Okay, these are uh, the advanced concepts we have. In addition to this basic concepts, we have advanced concepts also. We'll cover all these advanced concepts here.
Okay, thanks.
Okay. Okay. Any queries? Any further queries?
No, I think I've got what I need. Thank you very much.
Yeah. Thanks a lot. Thanks for your patience. Thank you. Thank you all.
Uh, th-
Bye bye.
Thank you very much for your time. Yeah.
Bye bye.
Yeah, thank you, sir. Bye, all. Thank you.
Thank you, Venkat.